Here's a shot with the cells in place in the front of the Jeep. And you see we have our component board held up with a 2x4 here. And we've spaced the cells so that they cannot move. They're in there nice and solid. We have them tied down so they can't go up or down, left or right, forward or back. They are now secure in this location. And once we're finished, we lower our component board here, and that allows us to, access them at will. There's 2 bolts that will hold that down in the front here. And so, yeah, one step closer. Next, we will clean off the terminals. Each one will be done, and then the interconnect will be connected. We'll be reusing those braided interconnects. And that'll put us closer. We're still missing the rear box. No rear battery box. They're having some equipment issues, and so we're waiting for the box. Hopefully not too long. Let's take a look at the dash. You can see we cleaned up the wiring that was hanging everywhere. And so now it's just ready for the battery box and the cells and interconnects. Once all those are installed, we will program our controller and she'll be ready to go. Well, first what we do is once we put the cells in, we'll charge them, and after they're partially charged, then we'll program the controller. But that will be the next hurdle. Hopefully the charger works and the charging system, everything works as it should. All this stuff is probably out of warranty now because it's from the date of purchase, and like I said, I think they started this in 2008, and I believe it's a 2-year warranty on all these things. 2018, I mean, not 8. And so, no matter how you look at it, it's beyond 2 years. So, that's what we're looking at the moment. Ugh. We're looking at pretty much the home stretch here. Once you have your cells in place and your components mounted, then the conversion's downhill from there. And so everything's installed with the exception of the interconnects and that rear pack. We're there. We're as close as you can get, just about. And so the thing is now is finishing that and making sure that we can charge our battery packs, and then that everything works. So hopefully there's no issues. When somebody else has handled something, you just don't know what you're up against. So we've tested everything that we can test, but there's things that we can't test until we have the traction pack up and ready to test. I'll be back. The front battery pack on the Jeep is wired up. Wired up. Anyway, there it is. The interconnect's in place. Notice we've left one out, and one that's easy to get to. And you wouldn't want to do one that's in the center and have to be careful not to drop it, short something else out. So you want it to be a good, safe location to install, an easy location to install. But leave that out. So by doing that, at my 2 points where this pack, the cables that leave the pack, there's no potential there. Okay, there's 0 volts. And so that's why we do that. We're going to leave that out until the very end, but that's just strictly for safety. So this pack does not have any potential beyond, the internals right here. And we'll do the same thing in the rear pack. And once everything has been done, then we'll do, the last link in each pack. And there's a process in which we do right before we put that last link in too. And of course, we share all that kind of information how to check for ground faults and so forth in our workshops. Well, in our last little segment, which is all going to be one video for you, but we were talking about we were still waiting on a battery box. Battery box is installed. We kept the original plate that they had in there to hold that box in place. We just kind of went with the path of least resistance, and so that's holding it in place, or one of the ways it's being held in place. And you can see where the 2 lines go out. And then the last shot we showed was the component board was completed, and we had done the interconnects on the front battery pack. And so let me bring you up to speed. Well, first let me kind of give you a little backstory. We received this Jeep, I believe it was January 23rd. On February 12th was that last segment. And today is May the 4th. So some time has gone by, and let me bring you up to speed to what's transpired in that time. In that time, we had some issues with some things, and we had to do a little more in-depth than we thought we needed to do. But we've got everything working with the exception of the controller, inverter, whatever you want to call it. That kept giving, I believe it's an error code 14 pre-charge. And so we did what testing we could do. It appears to be the pre-charge driver, and sent it in, and sure enough, that's the problem. But according to the Curtis Service Center in Pennsylvania, they won't repair that. So, and they were going to sell us a new one for over $4,000. We're like, we'll pass on that. We can get them a lot cheaper. So anyway, we ordered one, and of course, there currently is a worldwide chip shortage, and due to that, Curtis is not shipping controllers. So we're waiting on that. We just found out this morning that they don't know when they'll be shipping it. Originally we were told May 7th, which would just be in a few days. That's not going to happen. So here it sits, and you can see that it's not in the same location that it was back in February. So we've had to move this, and so things have moved on, but the Jeep has not. I mentioned that the Curtis controller in this CJ7 Jeep had a blown pre-charge driver. And the Curtis Service Center in Pennsylvania said they wouldn't repair it. And we ordered a replacement. They don't know when they're going to be able to ship one. And so this thing was just sitting on a shelf when all of a sudden I had an idea to try something, because, you know, we're waiting on all sorts of components nowadays. And so we basically have a full house and things are just sitting here. But this is one that back in the end of January when we took on this project, we thought it'd be an in and out project and that we could do it at the old warehouse, you know, at the same time we were searching for a new warehouse and all of that. Had no idea it would be here more than just a few weeks, maybe the most. Well, as it turned out, there were some bad cells. We had to replace those. We, you know, had to modify the front battery box. We had to build a rear battery box. There was just a lot more work involved in this than met the eye. And so when all was said and done, we could test it, we find out that the inverter, the controller, doesn't work. So, dead in the water like all the other projects at this time. But this one is a little different. We've got the parts, it just doesn't work. So what I thought of was that, well, if it's just the pre-charge driver, maybe we can circumvent that. What the pre-charge circuit does, and we'll take a look right here, it consists of the pre-charge driver and circuitry inside the controller, and a pre-charge relay, and a pre-charge resistor. So what happens, this is the Curtis 1239, they are has a 12 volt KSI input. So when you turn on the ignition, you go directly from the ignition, or in our case, we go through different safety features, and then you have the 12 volts at your KSI input, which is a solid blue wire on your wiring harness. Well, anyway, once this receives that KSI input, it then checks to see if the capacitors are charged, and if they are not, it turns on this pre-charge relay. That's all controlled by the controller here. So this pre-charge relay turns on. What that does is it takes power, which is here at your main contactor. Zoom out a little bit. You can see it's coming from our battery pack, goes through your main disconnect. And if the main disconnect was on, then you're going to have power right here to the main contactor. What the pre-charge does is it's going to bypass this contactor initially as soon as you turn on the KSI, and it's going to take power from this terminal, go through our resistor, through the contacts on the pre-charge relay, and then to this side of the contactors. You're basically just bypassing this contactor with a limited amount of current due to this resistor. And that's going to allow current to go into your controller and pre-charge those capacitors. Once the charger senses that the capacitors are pre-charged, it turns off the pre-charge relay, no longer bypassing the contactor, and then it turns on the main contactor, allowing full current capability to our controller, and thus then turns on your controller. So it all happens in a couple of seconds. You turn on the ignition, and in a couple of seconds you hear a clunk, and that's that main contactor being activated, and away you go. Well, in this particular case, that pre-charge driver is toast. And so what I decided to do is, let's manually activate this. It's a 12 volt, relay. Let's put 12 volts to it and pre-charge those caps basically manually and see if this thing will work. So I did that. I just basically, jumpered this. This thing was originally, to be controlled by the controller. And you can see I run into ground now, and then this is a 12 volt signal in, which I'll show you how that's activated in a moment. But we're manually activating this pre-charge, so to speak, and let it pre-charge those caps for a couple of seconds, and then send our 12 volt KSI signal to the controller and see what happens. Well, she fires up. So I came up with a little circuit to make this a little more automated and a little easier. And it actually, I think, is going to work out perfect in the big picture. So let's take a look at the dash and what I've done on the inside of the vehicle. Well, here's the dash of the Jeep. Kind of back out a little bit here. So let me come in from the other side. Maybe I can get a better view. Okay, so I'm the view from the passenger side now. So there's the dash. And the only thing I've changed is something that's very subtle. And that is that I added a little push button switch right there. Okay? So it's just I drilled a hole for that switch in this little steering column surround. So nothing in the dash. This can be, 2 screws and you can replace that. So, I have an aversion to drilling on people's vehicles. So anyway, we added that. It actually shows up more on the camera than it does, in actuality, which is kind of strange. Usually it's kind of the other way around. But anyway, in the big picture, what happens is we turn on the ignition on. A little red light comes on around that switch. The indicator light to let you know it's on. You can see the DC to DC converters drawing a few amps. 12 volt gauge tells us that DC to DC converter is charging our 12 volt battery. But what would normally be the case, you turn on the ignition, you wait a couple seconds, and you push this button. Push that button. There, main contactor just clicked in. And our Curtis 840 display goes through its routine where it shows HPVS, AC 51, and then goes to RPMs. And the light goes out. So that's all there is to it. It's actually kind of nice setup in that it kind of adds a layer of anti-theft, in that unless you know to, push that button to energize to turn on the controller. So let me explain it to you. What's happening is, and I'll show you the schematic. What's happening is when I turn on the ignition, it automatically turns on that pre-charge relay. And that pre-charge relay then is, bypassing the main contactor. Current's going through our relay and our resistor into the controller and pre-charging the controller. At the same time, of course, that red light comes on. Just as a little reminder. And once I press this switch, then that turns off, it activates the relay and turns off the pre-charge circuit and turns on the KSI circuit. I'll show you one more time. So turn the ignition off. Ignition's off. 12 volt gauge is dropping on. 840 display went off. Let's see if I can get a better look at it next time here. So, not drawing anything from the pack anymore. Everything's off. I'm going to turn on the ignition. We'll keep on the dash here. Okay, everything comes back on. The red light's on. I'm going to press that button. Bam. Goes through its routine. And to let you know it really does work, we'll just press on the throttle here. Well, what I know, what I did off camera the other day when I did all this, installed it, was testing it, turn this off. What found out was that the there's quite a bit of vibration, and the clutch isn't fully disengaging. So you put it in the gear and the vehicle wants to creep forward. So the clutch is not fully disengaging. Well, I just noticed something. When I put on the parking brake, the amp light comes on. It says amps. Thought that was interesting. Anyway, so bottom line, got the inverter to work. But we have some other issues that, of course, we weren't aware of until we could get the inverter working, or controller. And that is, I'm giving it throttle. You see the RPMs. It's a little noisy. And we have vibration. So the camera down here, let you listen. That's with the clutch in. Seems to vary. I've messed with it a little bit here. I'm always having the impression that there's not a Hmm. Noise has kind of changed. I guess we get it. Oh, here's a new one. Bottom line, I don't want to, but I think I need to pull that motor. I need to pull the motor and find out what's going on. One, try to eliminate some of the vibration, which is excessive. Two, try to identify why we have the noises that we have. And three, the clutch doesn't feel like it's fully disengaging. The other day when I did it, in gear and the clutch in, it would move forward or backward. Like the clutch wasn't fully disengaging. Today it feels like it's fully disengaging. So there's something peculiar going on. And so I feel we need to kind of do some further investigating. But in the meantime, or not in the meantime, before I pull the motor out, kind of like to finish one job at a time. What we need to do is we need to reinstall the chill plate, which was removed, reinstall the chill plate, reconnect our cooling system, get all that back and working, and then we can pull that motor and investigate. But I'm going to contact the customer first and clear it with them. I'm sure that they're going to want it done, but you know, the labor hours keep adding up, so conscious of that. The other thing I noticed, the power steering is quite loud on this one, and it's I think it's basically the way that they have it mounted. It's supposed to be shock mounted, but it actually is making some contact with the motor makes contact. I showed you that in an earlier episode. There's just not much clearance. So I'm thinking that's part of the issue, but that's kind of the situation. Like I said, I took it for a little test drive in the parking lot, and it didn't want to shift. You know, came to a complete stop before I go to the next gear. It just is not functioning as it should. So further investigation, and so we're going to look at that motor down there, check and make sure that the magic number is correct, check and make sure that our alignments and everything, just see if we can improve the overall balance on the flywheel clutch assembly, so forth. So that'll be next time. Almost forgot to include the little schematic that I promised. So here it is, very simple. We have our signal coming from the ignition switch right here. So we got ignition 12 volts coming in, and it goes to the two commons on our double pole, double throw relay. Then we have a single pole, single throw, momentary push button switch there, normally open. And we have the light that's in that switch, the little red light you saw. And then this goes to the pre-charge relay, to the coil on the pre-charge relay, and this goes to our KSI input, which in our case it goes directly, you know, from the fuse block, which is being ignition controlled through our power relay. If you look at some of the previous episodes. Anyway, so we get a fused 12-volt signal that's coming in, and then it goes to the same 3 layers of safety protection that we had from the beginning. Instead of going directly from the fuse block to that, it comes in through this relay first. So what happens, you turn on the ignition, power goes through the common here, through this set of contacts, through the normally closed, which lights up our little indicator light in the switch, and is going to our pre-charge relay. So the pre-charge relay is activated, and it is pre-charging our capacitors in the controller. As soon as you press this momentary push button switch, it activates this relay, this double pole double throw relay, which then takes ignition switch 12 volts through this line right here, which basically latches that relay. So once we let up on the push button switch, this relay stays latched through this line here. Then also, when that happens, of course, the power to our light and the pre-charge circuit is discontinued. But what happens then, though, is that this line here takes 12 volts through our KSI circuit. So very simple. Turn off the ignition, removes the power from this, everything goes off. Turn on the ignition, the light comes on, and power goes to our pre-charge relay, and we start pre-charging. We press the momentary button, it latches this relay, turns on power to the KSI circuit, removes power from the light and from the pre-charge circuit. It took, 2 components. It took the switch, which, has a light built in, and the double pole, double throw relay. That was all needed to bypass the blown pre-charge driver in the controller. So simple fix. Don't know why I didn't think of it earlier. Got a lot of other things going on, and it was just out of frustration that we've got these vehicles taking up real estate, and we're waiting on parts to get them out. So this is one we had the part. It's just that it had a problem with the pre-charge circuit, and so we just basically bypassed that. So I'm calling this a pre-charge bypass circuit, and works like a champ. And so now we're on to the next set of issues with this project, and is the motor clutch setup, flywheel clutch setup. There's vibration and there's noise that I don't like. So we'll be investigating that in the next video. What I originally thought was just an issue where they had overfilled the transmission and spilled onto the cross member, and it was, then dripping from there. As much as it has dripped on the floor over time, I cleaned up multiple, spills like this. Well, what's going on is every time this thing's moved, I mean, it's dripped a little bit all along, but when we had it transported from one warehouse to the other, it leaked quite a bit. And I thought just because, the oil, the fluid on the tray just moved around and came out the holes. This time we drove around the parking lot, just a quick little test drive after we got the inverter working. And boy, I mean, there's a lot. So couldn't see where it was leaking from before, but we're going to look again. And of course, we're going to be pulling the motor to figure out what the problem is there. I think we've got a clearance issue as well as you know, a balance issue. So we're going to be pulling the motor, but I got to clean this up again. But yeah, going to take a look and see if we got a seal that's leaking. But yeah, there's some issue. We'll see if we can't figure it out.